Hello everyone, welcome to the class. So in this lecture we will understand about the dynamics of a first order RL circuit. Means we will look at the response, how the response of voltage and current, uh, what is the nature of the response of voltage and current in RL circuits, right? So here I have drawn a simple first order RL circuit. So let's assume the initial condition, that is IL of inductor initial is 0, means before switching there was no current flowing through this inductor, right? So at t is equal to 0, the switch will be closed, so the circuit will look like this. Right, this is short circuit. Okay, so let's take this node will also become VL. Okay, and the current flowing through this inductor would be again 0 because it resists the change in current, is IL 0 minus, which was 0, right? It means it is acting like an open circuit. No current means infinite impedance, no and the circuit will act as an open circuit. See, okay, if it is open, then what is the VL across it? Okay, so all this current, this is IS, this is IS, so all this current will flow through this resistor R, and VL will become, again the same VL is appearing across this resistor because both of them are in parallel. So VL, let's call it 0 plus, would become IS into R, right? Let's call it equation number 1. Okay, so what does this signify? Okay, so it's a finite value, it's a finite quantity, finite value. Okay, and this VL was appearing across the inductor also. It means at t is equal to 0 plus, VL 0 plus is equal to L of d IL by dt. Okay, so VL 0 plus was IS into R, L DIL by dt. So let's see what does this equation wants to say. Okay, let's call it equation number 2. I think 1 was there, 2 is here. Okay, see everything is finite, means here if you see this is a finite quantity. So if this is finite, right, if it is finite, right, it will simply say, according to this equation, means it will say the inductor should change the current, right? Because this is saying that DIL by dt has to, it is finite value, right? Okay, so the current has the current flowing through the resistor has to change. So at t is equal to 0 plus, it was 0, now it has to change, either it will increase or it will decrease, right? So let us see what will happen, right? Okay, and in which direction the current will flow. At t is equal to 0 plus, you will see the polarity of VL was like this, VL of 0 plus, right? This was plus sign and minus sign at the bottom. So this will allow the current to flow in this direction from top to bottom. So this is how the current will flow. Now suppose this was the case, it is minus, this is plus, then the current will flow like this way from bottom to top. But we have got this kind of case, right? Why? Because the current was flowing like this way, right? This was the direction. Let me draw. The current was flowing like this way, this was the direction, right? So causing the plus means plus at the this top terminal and minus at the bottom terminal of this resistor, right? Okay, now the current will also flow like this. Okay, Now what next? Once the current has changed, now the current will increase also, right? Why? Suppose this VL is constant. So what will happen? So DIL by dt, suppose this is VL of 0 plus this is constant value, IS R upon L. Now suppose this is constant value. Suppose this is a constant. What will happen? IL would be like IS R by L with respect to T. So IL will increase, right? So we have got two things from this differential equation value. First, we came to know the direction, right, from top to the bottom, and the second thing, it will increase with time, right? It will increase with time. Now let's see whether it will really increase with my, okay, it will it increase linearly, or it will change the behavior. Okay, so for now let's assume that it will increase linearly, right? Because this equation, let's assume this is constant, right? Okay, so if IL will increase, what will happen? Okay, now what we were assuming that IL will increase linearly like this, right? T, this is I of L. So if IL will increase, so what will happen? The current through this resistor will decrease. Now it will come down like this way. As the current is increasing, the current through this resistor is decreasing. So the voltage, now voltage will also decrease. Now the voltage is decreasing. Again, see, if this VL is equal to L of di by dt, see, the one thing is that the polarity of voltage will not change, right? Okay, so the current has to mean the current will change. So because di by dt says the current will change, right? But the magnitude is, since the magnitude of VL is decreasing, it means the magnitude, the rate at which the current is increasing will also decrease, right? It means it will not go linear like this way, right? So at different point, it will, suppose here, now at some different point it will go like this, and then it will again like this, and again it will go like this, and after some time it will become constant like this way, right? Now why it is constant? See, if VL will be there, if any current is flowing through this resistor, let's see, if any current is flowing through this resistor, that will cause a voltage drop plus VL, and this VL will allow this inductor to change its current, and again the current will increase, although the rate at which the current was increasing will decrease, but the current will here. So what will happen in the steady state? In the steady state, slowly, gently, this VL will reduce, right? And this current will build up. And at some point, what will happen? All the current, right? All the current will, okay, all the current will flow through this inductor, right? I mean to say, it will bypass this resistor. And this is how it will achieve equilibrium. See, now if no current is flowing through this, 0, VL is like 0, no current is flowing through this, and all the current, if there is no current flowing through the resistor, it means all the current is flowing through this. IL would be IS. Wait, let me, this IL at infinite time will go to I of S. And see, if IS will become constant, so if this current becomes constant, it means the di by dt, means the rate at which the current is increased will be 0, right? The derivative of this constant will become 0, and again this 0 voltage is appearing across this. Now this is how the equilibrium will be reached, and this is how the RL circuit works, right? Any complex circuit will work like this. So what is happening basically, what we should deduce from this fact that, see, if in any circuit, right, it means RL circuit, right? So what will happen? All the current was passing through this inductor. It means this inductor at the steady state, it will act as a short circuit, right? Why short circuit? Let's draw a circuit. And see, suppose there is a resistor R and this is a short circuit. This has nothing to do with this inductor circuit, separate circuit. Let's call it I naught, and there is a R. So that definitely, if a short circuit path is appearing in parallel with this R, it means all the current will flow like this way, right? Because it is short circuit path. Same thing is happening with this inductor also, right? In our case, this was IS, this was R, right? And at infinite, okay, let me not short circuit. See, so at t is equal to infinite, after a very long time, all the IS was flowing through this inductor. This IL infinity was I of S, right? So we say in this steady state, the inductor acts as a short circuit, and at the switching instant, it acts as a open circuit if there is no initial current, right? Okay, so what we have learned through this circuit, that the voltage here, voltage was coming down and the current was increasing. So let's see the behavior mathematically, right? Let's solve this means differential equation and see what kind of response, what is the actual, means what is the mathematical behavior of the response of IL and VLT, right? Okay. VLT and IL of T, right? This node will also be at potential VL, right? Okay. So here I think KCL we will apply. This is IS. So IS was equal to VL by R plus I of L, right? Okay. As this is a simple KCL formula I have applied at node VL. Okay. Now what is VL? So we know VL is equal to L d IL by dt plus IL. So again we end up in a simple first order differential equation. The same equation means we have seen in capacitor circuit also, means first order RC circuit. Okay, so this is dIL by dt plus R by L into IL is equal to R by L into IS, right? And again this is a constant term, right? Okay, so here I can write directly that A e की power minus R by L into T plus some constant, let's say K. Again, this is a particular integral and this is the complementary function, or this is a steady state response, and this term, the first term, is like transient response, right? Okay, now how to evaluate K? Now this is a particular integral. The particular integral will satisfy this equation, right? So dk by dt plus, again this is, I have assumed constant, right? Okay, R by L into K is equal to R by L into IS. So this will become 0 because the differentiation of a constant will become 0. The R by L cancel, RL cancel, K would be IS, right? Okay, now the I of L of T will become A of e की power minus R by L T plus IS. Okay, now this is the equation. Now A will come, this will we can find out using the initial condition. At initial condition we know IL 0 minus was 0, IL 0 plus was 0 actually, So it will be 0. Let's directly put in the equation. So this is 0. Again, this is A plus IS. So A is minus of IS as we have expected. IL T is equal to IS minus IS e की power minus R by L of T. ठीक है, IL of T, take IS out, 1 minus e की power minus R by L of T, right? Okay, so this was the equation as expected, because if you see, initially the current was 0, and at in the steady state the current was reaching the IS value, and same thing which here we are getting, right? Okay, if I need to draw the behavior of the current, so initial and final condition is same, as you can see. No, not the same. Initial actually the condition is same like RC circuit. The initial condition from 0, the final condition is like IS, and the current would increase exponentially, just like RC circuit. The response is, the behavior of the response, the nature of the response is same, right? This is I of L of T. So the current was increasing from 0 to IS, right? Okay, let's see what is the behavior of VL. Would be, VL is like L di by dt, dIL by dt. So L here, and what is di by dt? IAS, right? 10 minus e की power minus R by L into T into R by L, minus sign के साथ. Okay, fine. So minus minus cancel, here L and L cancel. Okay, you see this will be like IS into R e की power minus R by L into T. This was VL of T, right? And here you can see, cross verify, at T is equal to 0, the current, right? No, the voltage was IS into R, right? So if you draw the response, VL of T, again it will be like decaying response, right? Here you see this is value is IS into R. So the behavior of the response of this of current and voltage is similar like R and C, but here in this case the time constant has been changed. Previously the time constant in the case of capacitor circuit was R into C, right? In the case of inductor it would be L by R, right? Okay, so here we have seen that the response in the inductor circuit is similar in the sense that means whatever we have seen in the capacitor circuit, the same kind of response we have seen here. So there is a some changes. So in the capacitor case, initially at switching instant it was acting as a short circuit, and in the steady state the capacitor was acting as a open circuit, while in the case of inductor at switching instant it acts as a open circuit, while in the steady state it acts as a short circuit. So in the coming lectures we will focus on few numerical problems just like capacitor QA sessions, right? So thank you.